Hi guys, so we're going to do things a little bit differently today. I know you guys don't have notes packets because I have them all printed here at school, but if you could just follow along as best you can, write down what you think is super important, which is a lot of it. I will get you a notes packet when we return to school and we'll fill them all out. I'll show you the key. They're kind of like fill in the blank. We'll see it when we see it, but let's just get through this. We'll do this, a couple multiple choice, and that will be it for today. So yesterday our topic was all about scarcity. Scarcity is having unlimited wants but limited resources, and it's what we're going to be studying. Every thing that we focus on in AP macroeconomics is going to come back to that term. And today we're going to apply it to a model. So in economics, we like to put things in a visual way. So we use graphs and we use models and we use charts to do so. So today we're going to learn our first graph. It's called the PPC, the Production Possibilities Curve, and it is topic 1.2. And we can't do this fun stuff that I had planned for class. But basically, here's what a production possibilities curve is. So a little review. When we put things onto a graph, we are not assuming that everything on the graph is true. We're kind of assuming that there is like everything is kind of held constant and just the things that we're putting on the graph are true and we're kind of forgetting about everything else. So for example, if this is the graph of the production, that means what we're making, possibilities, which is like how much we can make it, curve, and it's going to be a curve or a line on a graph. This isn't the only goods we can make. So a little math review here. This is your y-axis. And here's how I remember it. It looks like a Y. It's like the bottom of the Y goes really, really down. And this is your x-axis. And here's how I remember x-axis. It's like where you sign your name. Like sign your name by the X. So on our y-axis, we would have a good. And on our x-axis, we would have another good. Now, in reality, we're not just making two goods. We're not making like motorcycles here and cars here. Or Croc shoes here and tennis shoes here. We make more than two goods in America, in our country. Even in Lawrenceburg, we make more than two goods. But we're just kind of pretending that the only goods that we make are what's on the graph. Sometimes you'll see like consumer goods here and capital goods here, which is a little bit more realistic because it encompasses a lot more things. But here is essentially what a production possibilities curve can look like. We have two options. We can have a curved production possibilities curve, which would be an increasing cost. And we'll talk about what that means here in a second. Or we can have a straight line production possibilities curve. And it is basically saying that we can make anything that is within our means of production. So up here, we'd be making all of good 1 and 0 of good 2. Right here, we'd be making like half and half. Here, we'd be making more of good 2, but we're still making, oh, that was terrible. Oh, let me try again. But we're still making a little bit of good 1. Or here, we'd be making none of good 1 and all of good 2. So essentially, I'm going to put some points on this line. And I'm going to make them in some different colors here. So anything on the line, any point on the line of the production possibilities curve means that we are producing efficiently. We're just making different choices. This is like a half and half choice. This is more of good 2, less of good 1. This is more of good 1, less of good 2. But we are using all of our resources. We don't have a high unemployment rate. We have what's called a natural rate of unemployment here, which in America, the natural rate is about 3 to 5%. We'll get to that in a later unit. So anything on the line is going to be considered efficient. And you're going to have to excuse my poor handwriting all semester. Efficient means that we're using all of our resources. Anything below the line, like right here, would mean that we are in a recession or we're being inefficient. So sometimes we call this a recessionary gap, a recessionary place, where here is where we are fully employed, not like 0% unemployment, but a good rate, a natural rate of unemployment and using all of our resources. Here would be like we have some cyclical, some bad unemployment. Sorry, I'm using words you guys don't know yet. We have some bad unemployment above the natural rate. Not all of our resources are being used. But we have the possibility of increasing. We're just not where we should be when it comes to production. And so the last place we can be is up above the line which is not possible. It's unattainable unless we attain more resources. And sometimes people call this expansionary. We are expanding beyond our limit. And we're unable to make it there unless we acquire more resources. Well, what resources? What do you mean by that? The way that we can produce more is by increasing the 4 things that we read about or that we learned about when we talked about scarcity. Land, labor, capital, and entrepreneurship. So we can't make it here. We can only produce on the line. We can't get to this point unless we have some sort of expansion in land, natural resources, or labor. We have more workers available to us, or capital, more capital goods would get us here, or more entrepreneurship. That's a little bit more of a sticky wicket, but land, labor, and capital for sure. So let's move forward here. I have a real production possibilities curve. I was going to make you guys do it, but you guys can just watch me do it. I have taken this chart. In economics, sometimes we look at things in charts and numbers, and sometimes we look in a visual model, a graph. And so on this one, here is bikes versus computers. So we're going to imagine, and all these graphs are imaginary. They're putting a visualization of something that's not a 100% economic certainty because there's so many different factors when it comes to what's happening in the economy. But anyway, we're going to pretend that the 2 things this country makes is bikes and computers. And they can make 14 bikes. But if they make 14 bikes, then they don't have enough time, energy, resources, and labor to make any computers. So that would be this point right here. Now, what if they decide, okay, let's lessen the amount of bikes that we make? Well, let's make 12 bikes. Well, now we have the resources to make 2 computers. That would be this point. And so on and so on and so on. And I've graphed it all out for you and X this part out. Don't notice about that. So in this more like mathematical representation, an efficient use of resources would be anything within the chart. If we're at this point, yeah, we're making all bikes and no computers, but we're using all our resources. If we're at this point, we're making 5 bikes and 6 computers. And so we're making maybe half and half, but we're using all our resources. Well, over here, we just decide to make more computers and no bikes. And that's fine because we're still using all our resources. Now, if I were to choose a point like right here where I'm making 4 bikes and 4 computers, when I graph that, I notice that it is within the curve. Even though this is a straight line, we call them curves. I'm within the curve. And when I'm within that curve, remember, inside the curve means inefficient. And there's a little hint for you. Inefficient means inside the curve. Yeah, I can make 4 bikes and 4 computers, but why would I do that when I could be attaining a larger production possibility? That's recessionary. I'm falling behind, I'm receding behind the possibility. Anything efficient would be any of these points here, anything along here. And unattainable, well, what if, I don't know, the boss says I need 10 bikes and 6 computers? That point is out here, and that point is unattainable because we don't have the time, energy, or resources for that. We would need more land, labor, capital, and entrepreneurship. So unattainable would be outside the line. So here's where things get a little sticky in economics. What if we decide to make more of one thing and less of the other? And that is what we call opportunity cost. Opportunity cost is the cost of giving up the next best option. So opportunity cost equals opportunity lost. You chose to make computers, you lose out on a number of bikes. You choose to make bikes, you lose out on a number of computers. And we encounter opportunity costs all the time. Like right now, I'm choosing to make this video for y'all. My next best option was to, walk on the treadmill or read a book, something that I enjoy. And I gave up that next best option in order to make this video for you. The opportunity cost of me making this video was the opportunity that I lost that I really wanted to do. So we can graph that mathematically. Let me see what this next slide is. Yeah, here it is. We can graph that mathematically by looking at this graph, and I did a better version of it here. And you will see some questions like this sometimes. What is the opportunity cost of moving from A to B? So you would go to A, you would go to B, and you can do it on the graph or on the chart, and I'll show you in a minute. I prefer to do it on the chart, but from A to B, it looks like we went from 0 to 2 computers. So we added 2 computers, but opportunity cost isn't what you added, it's what you lost. What did we lose out on? We went from making an A 14 bikes down to 12 bikes. So we lost 14 minus 12 is 2. We lost out on 2 bikes. So the opportunity cost of moving from A to B is we lose out on the making of 2 bikes. Now we gain 2 computers. That's not what the question is asking. The question is asking, what do we lose out on? Okay, so let's do B to D, and then I'll switch and I'll do it on the chart way. So what's the opportunity cost of moving from B to D? I always like to circle the points. It just makes sense for me, B to D. So B, at point B, we are making, I believe, 12 bikes and 2 computers, and D, we're making 5 bikes and 6 computers. If you weren't sure, you could always just go back and look at the chart. But anyway, so when I move from B to D, and it says from B to D, I'm going to go down this way, and it looks like I went from 2 to 6. So I added 4 computers, but the question is asking me, what did I lose out on? I went from 12 at B down to 5 at D, and so I lost 7 bikes. So 7 bikes is my opportunity cost. Okay, so I'm going to go and do this on the chart so you can see if you were to ever encounter a question where you have an opportunity cost chart instead of graph, you could do it that way. So the opportunity cost of moving from D to B is what? So I'm going to go back to here, and I'm going to go from D, so I'm going to circle D, to B. And I'm going to think, what did I gain? What did I lose? It looks like from D back to B, I'm getting lost right now. From D to B, I gained 7 bikes. But from D to B, I lost 6 down to 2, 4 computers. So I'm going to go over here. I'm going to write we lost 4 computers. Okay? I'll do the last one for you too. I'm not going to make you do much today. I just want you to listen, watch the video and understand. So the opportunity cost of moving from F to C, there is no F. I probably meant E. Oops, sorry. We're going to change that. From E to C is what? So from E to C, I'm going from E to C. E to C, looks like I went from 0 up to 8 bikes. Is that 8 bikes? Hold on. What was that? Point C was how many? 9, sorry. From 0 bikes to 9 bikes. So I added 9 bikes, but what did I lose out? I went from 8 down to, I think that's 4. Yeah, 4. You see how it's easier to do it on the chart sometimes? I went from, where did I go? E to C? I'm losing myself, y'all. Oh, I went from 8 down to 4. So I lost 4 computers. So the opportunity cost is 4 computers. Okay? And then finally it says, what can you say about point G? Look at point G hanging out over here. Point G is unattainable. We cannot achieve point G unless we have an increase in resources such as land, labor, and capital. So that's a mathematical representation and a graphical, is that a word? Representation of the production possibilities curve. Now, I did some others for you because there are 2 different types of production possibilities curve. There's constant and increasing. And they're really super simple to tell apart because look at constant. Constant is a constant straight line, whereas increasing is an increasing curved, concave, bowed out line. So that's just the difference between them is their shape. And then I'll show you the mathematical difference between them as well. So this is a constant cost curve. A constant cost curve is the graphing of 2 things that are made from the same resources. So calzones and pizza are both made from pizza crust, cheese, marinara, pepperonis, sausage. They're made from the same stuff. So if I had to train my employees on how to make pizza and calzones, the training would be very, very similar. Right? I'm not wasting resources training my employees on both of these things. And if I have a pizza dude and I need a calzone dude for the night, I'll be like, yo, dude, go to the calzone side of the restaurant. Because they're so close to each other. They're made from similar resources. The training is the same. And so we call it constant cost because a lot of the things between these 2 goods are constant, including the opportunity cost. So take a look at this on my graph or the chart. Constant cost has another really identifying factor in that the ratio of the graph is constant. From 0 to 1 is 1, 1 to 2 is 1, 2 to 3 is 1, 4 to 3 is 1. You see how it's 1 all the way up? Same here, 0 to 1, 1, 1 to 2, 1, See how it's 1 all the way up? So the ratio of this graph is 1 to 1. The making of one pizza is the same time, energy, and resources as it makes to make one calzone. So if I were to say what's the opportunity cost of moving from point D to point B, I just have to count over 1, 2. It's 2. Or I could do the whole, well, I lost 2, but I gained 2. But it's a constant ratio. So hopefully you'll catch on to that pretty quick. And I did a 1-to-1 ratio. So moving forward. Increasing cost is a little bit different. It's the same thing that I just did on the other graph, but it has more of that like curvy shape. It's an increasing like curve shape. So these are two goods that are made from really, really different resources. But again, we're pretending that a country only makes 2 goods, which is ridiculous. But it'd be really hard to like retrain our employees and send them to the other side of the factory. Like we have a factory that makes pizza and robots, which is dumb and not real life, but we're doing an economic model. And all of a sudden we need more robots to be made. Move some employees over to the robot side of the factory, and you got pizza guys making robots. You're gonna have a larger opportunity cost because we have to like stop and train them on these resources and gather new resources because pizza and robots aren't made from the same thing. So the resources aren't easily adaptable to producing both. So in this case, you're gonna see that the ratio between points is much, much different. On one side, there will be a constant ratio. You see this? 1, 1, 1, 1. That's great. So 1 robot is equal to how many pizzas? Notice something, it changes every single time. Here it's 10. Here it's 6. Here it's 3. Here it's 1. What's the ratio? The ratio is different no matter where you are on the graph. So it would have to be a specific question that says, what's the opportunity cost? If I just said, what's the opportunity cost of creating a robot? It'd be like, well, crap, I don't know, because there's so many different ratios. It has to be much more specific. What's the opportunity cost of creating a robot between C and E? So if I create a robot between C and E, I'm gaining 2 robots, but then I'm losing out on 0 up to 16 pizzas. So you just have to be much more specific because the ratio of the graph is not constant. The ratio on this graph was constant, which is why it's called a constant cost. This one is called an increasing cost, okay? Side note, and I should have added this, and I didn't. Hold on, pause real quick. It technically, in the standards, there is a decreasing cost PPC. And it would look like this. It's not super important, which is why I didn't really put it in the notes. It would never be like, calculate the decreasing cost, because decreasing cost isn't really true to life as the other two are, increasing and constant. And the most you would ever see is like a multiple choice question with a picture of this saying like, what is this? And you would say decreasing cost curve. So that's why I didn't include it. We're going to push on forward. So shifting the production possibilities curve. If we wanted to push past to those like unattainable points out here. So like, let's say this is our original one. And we wanted to get out to a point right here. How can we push out our possibilities further? And keep in mind, this is a graph. This is a graph, meaning this is a number line. So moving to the right is more, moving to the left is less. And you're going to hear me say that a million times. Right is more, left is less. Right is more, left is less. Okay? So if we want to increase, we have to increase our production possibilities by increasing our capability, by increasing our number of resources. So the resources that will help us expand our production possibilities curve are land, labor, capital, entrepreneurship, mostly land, labor, and capital. So an increase in population would be an increase in labor. An increase in land, in natural resources, like more oil is being found and drilled, would increase. An increase in the number of capital goods being produced. That would be an increase in capital, and thus would push our PPC outwards. Okay, the opposite is also true. What if something like catastrophic happened to our population? I don't know, like half of us die. So that our population, our labor source, would decrease, meaning that we wouldn't go outward, we'd actually go inward, and the whole curve would shift. Now, sometimes things just happen along the curve, and sometimes it shifts to the right, to the more, or left is less. So that is like how we would shift PPC. land, labor, capital, entrepreneurship. Okay, we were going to do something fun and now we can't do it. I'm really sad. Also, this was supposed to be fun. Dang, this sucks. So all I want you to do, this is so boring, is just listen to this. I'm so sorry. This was going to be like a gallery walk. We were going to do like a dance to the PPC. We were going to do this fun. I'm not even going to tell you about it. Maybe we'll do it when we come back. Let's take a look at what happens if there is increases or decreases or things like that. So basically, what I'm going to do here is I'm going to show you like a scenario. And you're going to think, I'm not going to make you write anything down right now. You're going to think, what is going to happen to the PPC curve for computers and pizza? I think I did computers and pizza the whole time. So for this example, you're going to think before I flip the slide, and I'll give you I'm going to tell you pause the video because I'm not going to sit here forever. What happens if there's an increase in population? Ms. Keller just said if land, labor, and capital increase, then the whole PPC will shift. Then you'll think that. You'll pause the video, you'll think that, and then I'll zoop on and I'll show you the answer. There's an increase in population, which would move the entire PPC curve. Okay, let's do another one. Okay, what would happen if there's technology improvement in pizza ovens? So you got to think, in pizza ovens, there's technology improvement. What's going to happen to our production possibilities? Just for pizza. Okay, moving forward, here's what's going to happen. So the amount of pizzas that can be made gets pushed outward, but not the amount of computers, because the technology making pizza and computers are so entirely different, and that's why we call it an increasing cost curve, because it's two goods made from different resources. Okay, moving forward. Number 2, new computer making technology. Hopefully you catch my drift here. It's going to be the opposite. So the shift was only for computers because the resources used to make computers are so different from pizza. So we're going to increase the production possibilities of computers, but not pizza. All right, decrease in the demand for pizza. People don't want pizza. What is going to happen to our production possibilities curve? It was a trick question. The curve doesn't shift. Just because people don't want pizza doesn't mean we can produce less pizza. We still have the same land, labor, capital, entrepreneurship, and resources to make pizza as people don't want pizza. So why would we be making tons of pizza and not that many computers when we should be making less pizza and more computers if people don't want pizza? So this one was a trick question. You're welcome. Moving forward. Number 4, mad cow disease kills 85% of cows. Think about it. Do cows have anything to do with computers? Do cows have anything to do with pizza? There it is. So pizza production is going to go down because the capital goods, the things that go into making pizza, the cows that make the milk, that make the cheese, is going to decrease, but the resources to make computers isn't. So it stays the same, but the curve kind of zoops inward. Okay. Number 5, destruction of power plants. Okay, this one gets a little bit different. So actually, from now on out, I'm going to use a very classic economics example of guns versus butter. And I know you're like, Miss Keller, that's so stupid and also kind of violent. Why do we use guns versus butter as an example? We're going to use it as an example all year. Because guns represent like military goods or, military goods, which our country considers to be a capital good. It's used for a purpose. And then butter is just like a consumer good, okay? Really, I would prefer like robots versus butter, but this is the stuff that's in all the economics textbooks and like videos and stuff like that. So the making of capital goods, which was goods made for other purposes, like tractors to farm, plumbing trucks to get all the supplies to the job site, an oven to make bread. The consumer good is made from the capital good. A consumer good is just like you or your family buys it and you use it and that's it. It's like a one-time, and it might not be a one-time thing, like my couch is used all the time. That's a consumer good. But it's made for one purpose for one family. That's more of a consumer good. So if a destruction of power plants occurs, and we're making capital goods versus consumer goods, power plants power our whole country. So all of our resources are going to decrease. The production possibilities for both of these things are going to go down because we need energy in order to make all of those things. So sometimes these questions will impact both good 1 and good 2, consumer and capital. Let's do number 6. Faster computer hardware. Faster computer hardware. This one, computers are going to be used to make capital goods and consumer goods. And so this resource, this new capital good is going to shift our production possibilities outward, and we can make more to a more attainable spot way out here. Okay? Many workers are unemployed is the next one. So we've got people not working that could be working. It's not that they're dead. It's not a change in labor. It's just they're not working. So the curve doesn't shift at all. This is another trick question. Unemployment is just a point inside the curve. This would cause that recessionary. So here is this like natural rate of unemployment. If more people are not working than like should be working, this is like an unnatural rate of unemployment. It's a recessionary point. Okay. And last one, significant increases in education. So a more educated population, more educated workers, that is going to impact our labor force. Land, labor, and capital is what can increase this production possibilities curve. And so labor that is better educated is going to shift out our production possibilities. They're going to be able to make more and more and more. One thing that I'm going to like ignore this, that I just want to touch on real quick before you do the multiple choice is I want to point out that if I were to ask you the question, maybe I will in the future, which is better to make? More consumer or more capital or right in the middle? So if I like gave you this option, burp, 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 you would probably be tempted to say, oh yeah, like right in the middle, right? We need military goods, we need capital goods, we need machinery and robots, but we also want like butter and French fries. So like right in the middle. And you're right, for your happiness, being right in the middle, this point right here, let's call this point B, let's call this A, let's call this C. Point B would be better for like your happiness, your population. But when we think about future economic growth, when we think about the future of our country, we want more capital goods. The more capital goods, the more crap we can make in the future. So point A is going to be better for the future, better for economic growth. I'm going to put increase econ growth. Welcome to my terrible handwriting. My A-push kids know what I'm talking about. What if I put it this way? What if I said, okay, capital goods is like Chromebooks and consumer goods is like cans of Diet Coke. And I said, okay, which one's better, A, B, or C? You'd be like, oh, duh, Chromebooks, because capital goods are going to help kids in the future, whereas Diet Cokes, Miss Keller's just going to drink them all the time. So I just want to throw that out there for you. So what I'm going to have you do now is I'm going to number these accordingly. This is going to be number 1. You're going to pause the video. You're going to read this, take a look at the question, and you are going to comment on this post on Google Classroom, and you're going to tell me what you think the answer is to number 1. Pause the video, do that. Okay, moving forward. Now you're going to do number 2. Pause the video, read it, comment on Google Classroom what you think the answer is. And then you're going to do number 3. You're going to pause the video, read it, comment on Google Classroom. And you are done for the day. Thank you so much, friends. Sorry, this is non-traditional. We'll get you your notes packet eventually. Hopefully you wrote something down and hopefully you learned something.